first speaker up is Cathy Almond, working for Internet System Consortium, and her talk is Thinking About Serve Stale.
This is going to be a combination of tutorial and presentation and some questions. So this is part of trying to introduce a little bit more operational material. Some of you will know what serve stale is, some of you are already using it. And yes, I'm Cathy Almond, I work for ISC, but I'm also talking about some other software providers' products. What is serve stale anyway? So most internet users, the little user sitting behind their laptop, relies on the DNS without even knowing about it as the mechanism for getting to where they want to go to. And what sometimes happens is that some disaster will occur. It's always the DNS. I mean, see the T-shirt. But it's not really the DNS. It's usually the people behind the DNS. It could be that the DNS services are down because, I don't know, maybe something hit the building the DNS server was in. Maybe the DNS service providers' servers were attacked under DDoS. But whatever, if the DNS is not working, then you are not going to be able to get to the services that you want to get to. So DNS is important. Serve stale was introduced after a bit of a big famous disaster in about 2016 when some services went down and a lot of internet tools like Netflix and so on were unavailable. And management said, oh, this must never ever happen again. DNS people, find a way to stop it happening. Your resolvers knew how to get to these places, but because they couldn't talk to the DNS servers, everybody was down. Fix it. So that's where serve stale came from, and everybody rushed to implement it. And the concept is, so imagine your resolver is a refrigerator, and it has things in it that you have bought to eat. And you carry on providing those to your users until you run out, so they're not there anymore, or until the use-by date on them, that's the TTL in your records, has reached an end. And then suppose you can't go to the shop, or the shop hasn't got any stuff, but you still have some bread in your fridge that's gone past its eat-by date, but you can't get any bread and you need some bread. So the concept is, well, it's not that bad. Use that old bread that you've got anyway if you can't get any bread at all. So the software was developed before the standards. There is an RFC for this, and it's a delightfully well-written RFC. It's quite nice because it's not full of very complicated technical stuff. So if you are not a coder, it's good reading. I realise I can't see the monitors now that we've moved this. So there's a slight practical problem with the location, so I'm just sliding over slightly. So, very quickly, how might this work? Well, resolvers have caches. I'm going to take my glasses off and actually just read from the monitor. How long do you want to keep the stale content in cache for? I mean, you're keeping it, but you might throw it out. But if you want to possibly serve things stale, then you're going to have to keep it for longer. How long do you want to keep your customers waiting for an answer? So, I mean, how long does it take to try and get to the authoritative servers and not be able to speak to them and it fail and your client's gone away and given up? So, yeah, how long do you want to do that? How often do you want to try again? Because if you've tried once to get it, is it worth trying again in the next second? Is it worth trying again after an hour? Should you try more sooner than that? So that kind of thing you need to take into account. And when is stuff too old to use? I mean, you've got your bread. It's still usable. It's only just gone past its serve stale date. But in a couple of weeks' time, it's probably absolutely green and horrible, and you would never want to use it anyway. So there's all sorts of considerations to take into account if you're going to implement something like this. So the RFC itself has given some guidance on timers. And it's more or less what I said before, so I'm going to skip over this. And as I said, this is a primer as well as an info thing. Aha. But the RFC also talks about, okay, you've given somebody this stale stuff. I mean, it might have come in with a time to use of 2 weeks. Are you going to give 2 weeks, or are you going to give several days old responses to your clients with a 2 weeks TTL on them? Nah, you want them to come back and get the real stuff if it's available. So that sort of thing needs to be taken into account as well. Also, what is not being able to get the data? I mean, is it just that the servers don't respond, or maybe they respond with some sort of error? There are all sorts of things that you have to take into account. If you're giving somebody old stuff, are you going to tell them that you're going to be giving them old stuff? At the time this was originally written, there were no such things as extended DNS errors. There are now. So, yeah, we can use EDE codes for that. Okay, enough of the theory. Let's talk about actually using it. If you were going to enable it on your resolvers, there are 2 main things to think about. The first thing is, if you're going to be keeping this stuff around, even though it's expired, you're keeping it in cache, but your cache is going to be potentially holding more data than it did before. That is a consideration, a significant consideration for resolver operators. The other thing to bear in mind is what you want your client user experience to be. You know that you're going to give them the old stuff because you can't refresh it, but how long do you want them to have to wait until you give them the old stuff because you can't refresh it? So, I'm going to cover bind, which obviously I know about because I work for ISC, unbound from NLNet Labs with a little help from my friends, similarly Notch Resolver and Power DNS Recursor. So the subsequent slides, I have upended how you would normally do a presentation. So a regular presentation has bullet points, and then the presenter elaborates on a little bit more background. I'm going to do the opposite. I'm going to give you the slides to take away as a primer, and so I'm going to say less about them. So listen to what I'm saying if you want to know what's different, and take the slides away as a read later. I'm going to have to put my glasses back on now because I really can't read that from there. So, bind has 2 main things that you can enable. It is retaining the stale cache or retaining the stale data for a set extra TTL in case it's needed. And then the second thing that you've got that you can enable is activating the processes to serve this. So you start off and you say, okay, do I want to keep this stuff to use it? Maybe, and that is stale cache enable. And then there is, do I actually want to provide stale answers if I can't refresh them? And that is another setting to turn on. You can turn it on always in the configuration, and then you can tweak it dynamically and turn it off and on. And that's using RNDC, or you can, the other thing I was going to say was if you haven't got stale cache enabled in the first place, there is no way you can serve it stale. And there is one other thing. No, that's the next slide. I was going to say, however, though, if you're enabling stale cache, but you don't know whether you want to use it or not, and so you haven't enabled that bit, how do you know when you need to use it? So would you enable stale cache but not turn it on, not turn on stale answers? It doesn't make sense to me, but anyway. Okay, here are all the knobs that you have. The knobs are kind of the control knobs that we saw in the things that you might want to think about. Most of them are tweaking how long you keep the data for, how long you wait before you try again to refresh it. There is one very interesting knob, stale answer client timeout. Now, this is the one where you think about the client experience. How long do you make the client wait before you actually give them the stale answer, but maybe carry on refreshing in the background? I mean, it takes quite a while to prove that you can't reach the authoritative servers, longer than the average client is going to wait. So the concept was originally, well, okay, let's make it a little bit shorter. We started to try. It looks like we're not going to get an answer. So give them the stale stuff and carry on in the background. We had a lot of fun with this one. So in bind, we've eventually come down to, actually, you can't set it. You're just going to have to make them wait. Or let's set it to 0. And what that means is, client comes along, the content's expired. OK, give them that. We'll go and refresh it afterwards. So it's kind of serve stale first and refresh second. I'm going to discuss a bit later on whether you'd want to do that and whether or not it's a good thing. By the way, bind's not the only one that does this. So the biggest takeaway point on enabling stale cache and stale serve in bind is the cache. The reason for this is bind has 2 cache cleaning mechanisms. One of them is based on going and looking at the expiry of records. And in general housekeeping, as it goes through, it just removes the stuff that's expired. Well, clearly, if you're hoping to use expired content to provide stale answers, you're going to have to keep it around a bit longer. Which means that in bind, if you enable stale cache, you're going to get a bigger cache. And the likelihood is that you will hit the cache limits type cache cleaning. In bind, the cache limit, the cache memory cleaning, is less efficient than the routine housekeeping. So that's something to bear in mind if you're thinking about enabling serve stale in bind. And PS, yes, we do EDE. We started off doing both error code, both EDE codes, 3 for we've given you stale answers and 19 for, hey, we've given you stale negative answers. But a little bit later on, we decided that we weren't going to keep negative answers available for stale. So actually, 19 doesn't happen anymore. OK, unbound. It started off with one very simple setting. Serve expired, yes. And if you did that, then anything was eligible forever, as long as it was in cache, to be served expired or served stale if it wasn't possible to refresh it. That works because unbound doesn't have the housekeeping thing that bind has. But alternatively, you could say, OK, so how old is too old? So a little bit later on, they added the serve expired TTL, and the default is 1 day. They also recommend using prefetch, because that helps you keep things refreshed in cache before you even come to ask them. In fact, you could do that in bind as well. And then there's a very, very subtle option, which is served expired TTL reset, yes or no. And it took me forever to get my head around it, and probably several hours of discussion with the engineers, to be honest. And it is about... am I going to explain it? No, I'm not going to explain it. Come and ask me afterwards, because it is so subtle, it'll take me so many words to explain this to you that I'll get completely tied up in knots. But yes, it is an option to be able to carry on, but there's some interesting variants on behaviour. OK, so we have configuring the classic options again. So you've got what TTL do you want to give on the answers that you give. You've got how long do you wait to time out the client and then give them the stale answer while the refresh goes on in the background. And again, the architecture is very different. The default is 1.8 seconds. I think it's 1.8 seconds because your average client waits 2 seconds for a reply. So the idea is, OK, we'll just wait. Nope, you can have this, and then we'll carry on. So you don't have to worry so much about cache with unbound. That is because unbound's cache cleaning strategy is already let the cache fill up until it's full, and then use a least recently used strategy to clean it. So there is no regular housekeeping. So you're unlikely to run into cache memory problems if you enable serve stale in unbound. Ooh, I never mentioned TTL 0. Okay, unbound and also bind, actually. So when content is received with TTL equals 0, whether you think this is a good idea or a bad idea, the idea is it signals to the resolver, do not keep this in cache and reuse it ever. It's a one-time use. Several of the implementations, including bind and unbound, have a way of overriding this so that the minimum value that they will store in cache is greater than 0. In other words, TTL 0 is not being observed. That, in most cases, is going to cause the content to be available to serve stale, even though it was received with TTL equals 0. TTL equals 0, folks. You had it coming. Right, and particularly in not resolver, which I haven't got to yet. Okay. Very simple setting. Serve stale equals true. And as it says on the box, that is how it happens by default. Again, not works like unbound. The cache cleaning strategy is based on let the cache go to its limits and then start evicting things to make space. So it doesn't have a setting, or you don't have to set or think about anything about cleaning it up and housekeeping. Not by default actually overrides TTL equals 0 anyway. And I did dig into this a little bit more. Although it overrides TTL equals 0 content and serves it with a greater time to live, and it does also make that stuff eligible for serving stale because it hasn't got a TTL 0, even if you take the default down to 0 so that you are actually accepting that the stuff has got TTL 0, it's still served stale or eligible for it if it can't be refreshed. As I said, you had it coming. Not resolver does do EDE options as well if you're running something new enough. And you do have the ability to say how long to wait before retrying. And Power DNS. This took me a little bit of a while to get my head around because it's a different approach. So everyone else said, oh, okay, so we need to set timers for how long we're going to keep this stuff and when it kicks in and when we actually do serve it stale. Power DNS said, okay, we're going to do serve stale extensions and how many times do you want to do it? And by default, if they're serving something stale, they send it back with a TTL of, no, they don't. Initially, they'll send it back with a TTL of 30 seconds. But what they actually do is, instead of saying, okay, well, we know it was TTL 1 day or something, but because we're serving it stale, we're going to serve it for only 30 seconds, they actually reset the counted down time to live in cache to 30 seconds and then carry on counting it down. So it serves both as this is what we're going to serve the TTL on it as well as this is how long we're going to serve it before we actually try and refresh it. Kill two birds with one stone, don't you? So the count, how many times can you reset that 30 seconds? And that determines how long, how many times you've actually served it stale and eventually it's got worms and really you can't serve it anymore. But it does, but the revival does take into account the TTL that you gave or how often you queried, so it does work out at the end of the day. One of the questions I asked was, well, suppose you reset it to 30 seconds and then an hour later you reset it to 30 seconds. Does that mean you've added an hour to your whole period that you've got it? No, it does the sums properly. And I didn't move my slides on properly, did I? Sorry. Are we on not covered? No. This doesn't seem to be where I thought I was. Okay, that's just me, I think. Right, I stopped at those 4 servers. I had gone down enough rabbit holes. I did look to find out, if I could, what other implementations had Surfstale in them. Anyone using the open source software that I've gone through as an appliance and have it inside the box almost certainly have knobs and controls and this feature enabled. Akamai DNS has a switch to turn it on. The cloud-based services, nearly all of them have this kind of feature available. So it's out there, and ask your software provider. Okay. I didn't cover a bunch of complications. Again, you can read those on the slides. If you need to know what other details there are, ask your software provider, and they'll be able to fill you in. And finally, the challenge. Is this actually useful? So there was a big rah-rah at the time. It was designed to cover the enormous internet emergency. Half the DNS servers have fallen down a big hole. What are we going to do? Scenario. And so everybody said, we must have this. And so it was put in, and people have started using it and enabled it. I don't think there have been any disasters of that ilk since, but a lot of people are using it. How do you know it's actually working? I mean, if there was a disaster and the auth servers were down, but you had this enabled, how would you know? I have no idea. I get a lot of pushback from engineering saying that this is, I mean, honestly, it was done for this, it's a waste of time. I have a different suspicion. My suspicion is that it's papering over the cracks, quietly and helpfully, and nobody knows. Are you monitoring it? If you've enabled Surfstale, have you looked at the logs or the stats or anything like that? I would love to know if it's actually useful. So my challenge to you is, if you've enabled it, or you're thinking of enabling it, or you're going to go off and run it, please go and have a look and find out if it is doing any good. Because I would love to know, maybe there's another presentation in this, about how it's really working, and is it actually useful. And some stale bread.
Cathy, and I see we already have a queue, so please go ahead. We have 5 minutes for questions and answers.
No. I'm loving that you guys are so far away from me. Hi.
Over there.
Yeah. Oh, now it works.
It's going to be first in line.
Okay, Puneet from Google Public DNS with the public DNS hat on. So to your question of is it useful? One is I can mention one simple statistic. It's a very basic statistic, but 4 out of about 10,000 queries on our system get answered based on Surfstale. So that's one piece of data. Is any large domain or domain people would care about in this room on that list? Probably not. But this is where I would point out one of the main benefits is going to be for low probability, high impact events, right? I think all of us don't want that event to happen, but when it happens, that's when we'll really know how useful it is.
I think you probably would know for a high impact, low probability, because it would be all over the news.
When it happens.
When it happens, not if it happens. Warren Kumari, Google. So I'm not entirely sure that I agree with the characterization that this was specifically for the sort of like Dyn type outages, the massive ones. I think this still has utility for when my 2 personal auth servers fall over. Yes, that's not affecting everybody at the same time, but I happen to care about my name. And so even if the rest of the internet is up, if my servers are down and this gets used, to me that still seems like a feature, not a bug. So Puneet's numbers of, what's that, 0.4% of all queries or something? 4 out of 10,000. So 0.04.
I did
Point
want
zero
to,
zero.
I did
Some
want
number.
to know from Puneet actually, when the, sorry Puneet, I'm forcing you to drag you up. When you get this, whatever it is, 0.4%, how long does it persist for? Is it the same servers or does it float around?
I think we didn't spend a lot of time looking in detail, but it's a mix, some common ones and some moves around. But if you ask, is it in the top 10,000 list of domains on the internet? Mostly not. And just to be clear, it's not 0.4%, it's like 0.004%. So it's
Minuscule.
Yeah. Yeah.
So we're talking the cracks in the road, not the big potholes and not the great big collapsed into mines holes that you get in Cornwall.
Yeah, I think, but the point there is if DNS was behaving that badly, we have other problems.
So I'm going to try to keep time. We have 2 minutes, probably 1.5 minutes. So please make it fast.
Hi, Dave Lawrence, Serve Stale author and original implementer for Bind 9. And I will say thank you very much for the compliments on the draft. And I guess that's all. No, so I'm no longer at Akamai now, but when I was at Akamai, we had logging and stats that absolutely indicated the, in quantitative terms, the cracks that it smoothed over. So yes, it wasn't stopping major incidents, but there was plenty of evidence that, particularly for some customers who we needed to talk to their origins, because we had resolvers all across the edge, right? We had 10,000 resolvers around the network. And so papering over those cracks was very useful for a subset of customers who in particular had problematic DNS. And qualitatively, I can say that the customer support very much appreciated the reduction in calls that they had for like poor performance issues and so on.
Okay.
I am very sorry, but we do have to cut it off unless the PC chair
Can I just make
want
one
me to
comment?
run over time. But I want to make sure that Shane has the time allotted to him.
Can I just make one comment here? The Trenco Top 1 Million contains 119,000 domains served by a single IPv4 unicast name server. So what it's really saying is you may not see it a lot because this is the dross, but there is a huge number of folk that know nothing about the DNS that are provisioned in a way that serve stale helps them because there's no resiliency in their arrangements, right? There's nothing. And serve stale backs them up in a way that nothing else will do it. Thanks.
Just another comment, because I just looked at one of our servers. It's a bit less, it's 0.001%, but I mean, this thing is happening. Yeah.
Okay, cool.
Thank you very much. And thank you for keeping the last comments quick.